This meeting is being recorded.
We're told in chapter 20, problem 4 here, that we have these two structures that are constitutional isomers, so that we know they have the same molecular formula, but we're asked to determine which of these would be the more acidic compound, and then we'll also justify our choice as to why we make that decision. So if you recall, to determine the more acidic compound, generally you would deprotonate the compound. So I'll remove the acidic proton on both of these here. And then we would look at our conjugate base. Mainly we would determine whether or not the conjugate base would be resonance stabilized. So we see here in this first compound, this would be the conjugate base over here, that this is not a resonance stabilized conjugate base, and therefore we would finally determine that this conjugate base would be stronger than the one over here. So let's take a look at the conjugate base that results from this compound here. So once again, we're going to deprotonate this. And then we can see that this would actually have a resonance structure. So if we were to move one of these lone pairs here, we already have two lone pairs there. We'll move one from this pi bond up. We can actually see that we could generate this resonance structure here, where we have three lone pairs on that oxygen. And then now we have a pi bond here with two lone pairs. So because this compound here, it has a resonance stabilized conjugate base, we would say that it would have a weaker conjugate base. Therefore, we know that it would be a stronger acid by comparison. And that is why we would determine this compound on the right to be more acidic, because it has that resonance stabilized conjugate base, like so.